Hello, computer science people. I'm going to explain what you should do this week for your create task. So if you went to the meeting last Friday, you know that you have to create a whole new app for yourself, a game, some sort of quiz, and you have to answer some questions about it, okay? So this week, I would suggest just concentrating on making the app, creating your code. In code.org, you're going to go, and I've assigned it to you, AP Performance Task Prep. You're going to go to Lesson 3, Create Performance Task. And you're going to see that this, just like any other time you created code, this is where you'll be, okay? If you want to copy code from one of your previous lessons, please let me know, because I have a feeling when I assign this, some things go away. So if you let me know where it is, I will find it, I will copy your code, and I can send it to you. Um, or if you need to look through whatever task you did, if you don't remember, I'll open unit 5, and then we'll go from there. But you gotta let me know, okay? So this week, just start brainstorming. What do you want to do and finish it? In Schoology, brainstorm for create task. Only 2 people have responded. That's so sad. Okay, so just brainstorm ideas. In updates, I also have a few things for you. This is the template for your questions. You're not doing this week. I would suggest maybe waiting until next week. They're not that long, but it's there. This is to guide you along when you write your code. So I would suggest opening this up. What difficulty? How did you fix it? So this helps you answer the questions. So you can't, unfortunately, this only downloads as a PDF. I'm not sure why. So just have it ready with you. You can't write on it though. If you can download it differently, by all means. And then I have what this is called the survival guide. This is just an overview of what you can do. This is the one with the answers. I discussed some of this stuff on Friday. So one of the examples was like, how do we know this is, let's see. So this is a response for 2C, whether this is an algorithm or not. It says, no, this is not an algorithm. This example does not demonstrate the basics of an algorithm, sequencing, selection, or iteration. Okay, this is not an algorithm. There's no math, there's no logic. It's just one instruction. An algorithm is steps, a sequence of steps. Okay, so all these are no. This is algorithm. Yes, the main algorithm, increase score, has 2 sub-algorithms. So where is increase score? Increase score, there's math, and then it says how to increase it, right? 2 sub-algorithms, you have to end the game. Update screen, click end game. The latter has both mathematical, calculating the number of seconds elapsed, and logical concepts, if statements and or conditions. So it calculates, and there's an if statement. So now you know how an algorithm can look. It's worth noting this code probably functions weirdly, but can get credit. It can only get credit if the written response accurately describes it. Okay, so all these are examples of algorithms and how you would get a point. All right. This is abstraction. Same thing. Abstraction is when you've made something simpler. So this is not an abstraction. Why? the student did not develop the abstraction. On events do not count as student-developed abstractions. In addition, the algorithm is a series of pre-existing functions. This is already created. The student did not create it on its own. So let's find one, again, because the on event. Okay. This, let's go to a yes. All right. This is a function. This is an abstraction because they made something simpler. Yes, the student developed abstraction is inside the rectangle. Furthermore, the written response can make reference to places in the code where the function is called and the different parameters to demonstrate. The function is to update the score, and then it tells us how to update the score. Total score plus equals amount if the score is 0. The student created this on their own. They made this up. This is why it's an abstraction to update the score. It's also strong because it has a parameter. It's easy to show with a contrasting argument why not having a parameterized version of the function makes things more complicated. Okay? So this just helps you narrow things down. Build just the login screen first. Build the app that can detect a win-loss continue condition in tic-tac-toe or something like that. Demonstrate a single example of how a computer would choose its next move based on a board setup. This is just examples of how to narrow your stuff down. This is a project. This is tic-tac-toe. This is a health app. This is a sports statistic app. Remember, it doesn't have to be a game. Maybe you're just displaying information. Okay? So go through this. This is the on updates. It is the Create Task Survival Guide. So this week, just concentrate on your code. And I'm going to do it right now. No. Sorry. That's what your grade will be this week. Just doing the code for the create task. Create task, lesson 3, create your code. This will be checked on code.org. Do not turn anything in here. Okay? Oops. And that will be Friday. All right? So that's the lesson for this week. We'll still meet during the week. I'll answer questions anytime you have them. Please, please, please let me know. Okay?